Hey everybody, it's been a long time since I've made a video for you guys about a particular topic. This semester's been very different than last semester as far as scheduling goes, but I wanted to make one to go over some of the key topics about this week's unit. And this week we are going over magnetism and static electricity. Now, for today's assignment, the actual assignment for today is really just take notes. I want to see that y'all are taking notes on topics. This is the only week we're going to spend on this particular topic, so I wanted to make sure I got for you guys the specifics, some of the big highlights of the unit. Expect to have a quiz kind of at the end of the week, and then we're going to move on to actual electricity for a couple of weeks with after magnetism and static electricity. So, anyways, here we go. In your assignment, like I said, I created a Google Docs page, and really you should just be typing your own notes, vocab, what you feel is important, and then when it comes to the quiz, you can always use that on your quiz. You don't have to be able to edit your assignment, but you should still be able to open and view it once you've already turned it in this week. Okay, so strap in, get your notes ready to go, and let's get to it. All right, so the way I'm going to work this today is I am not going to go like I used to through every single slide. We just really don't have time for that. I do need you to go through and read all the slides and whatnot, and I'm going to move myself over there. So, a lot of this I feel like is fairly straightforward, but some of the main points I did want to, like I said, highlight for you guys. For example, this bit right here, you should already know from life that with magnets, opposites attract, so north and south attract, and like poles repel. But you may not know that if you cut a magnet in half, you actually get two magnets. You end up with a north and south on each one. So you cannot separate north and south, and that's not true with static electricity. Electricity, as you know, is positive and negative. You can separate those two. So that's an important difference between magnetism and static electricity that we're about to get into. North and south can't be separated. Positive and negative, you can. Okay, so moving on. Like I said, opposites attract, like poles repel. There are two types of magnets. There's permanent magnets and temporary magnets. Remember, you can pause the video if you need to. Permanent meaning always a magnet. Temporary meaning can be a magnet sometimes. Like if you pick up a nail with a magnet, well, that nail is now a magnet for a little while, right? It can pick up other nails. If a nail can pick up other nails, it's magnetic. That's a temporarily magnetized object, okay? There are no liquid magnets. It's got to be a solid because it has to do with the organization of atoms, okay? And when we talk about the magnetic fields themselves, I like this picture a lot. A lot of people just skip past the title slide. Take a look at this picture. This picture shows ground up iron, we call them iron filings, that have been sprayed around a magnet. Sure, you see that it clumps at the poles, north and south, but notice these curved lines. These are actually super important information that we're going to get into because what these are magnetic field lines. And it is vital that you are able to draw a magnetic field and understand what is going on here. So, first of all, magnetic fields come out of the north and go into the south. And they make loops. If you could see inside this magnet, these lines don't just stop at the poles. They actually go all the way through the poles and make closed loops of magnetic energy. Okay. Now, this also shows and explains why opposites attract and like poles repel. First of all, where the field lines are closest or strongest, so the poles Out here would be the weakest, right? And that these lines never cross. Now let me see if I can copy and paste this. Take a look. If I bring two magnets near each other, opposite sides, south and north, this shows why opposites attract. Look at these arrows going in the same direction. That means as you bring them near each other, they will pull each other towards each other because these fields are flowing in the same direction, creating one big magnetic field. Now, if I do the opposite, if I bring south near south, look what happens here. Now you have the fields pointing in opposite directions. Same is true if you bring north on the other side. But you have like poles repelling, pushing against each other, creating a push. Like these arrows are going to push against these arrows, and that's why they don't want to touch each other. That's like the elementary thing to do, right? Is try to take two like poles and push them against each other. But this shows right here why they don't do that. Is these fields literally spin and push against each other. Okay? That's the basics of magnetism, is these field lines. And that's why it's so important to draw them. You can see where it's the strongest, and it really shows why opposites attract and like poles repel. So, next thing. Where the magnetism comes from. When you read about sound and thermodynamics, you should have learned a little bit that atoms vibrate. They move. Okay. Atoms don't just vibrate and move. They spin. And they all have their own little magnetic fields. So these are atoms. They spin and create a flow of magnetic energy. Every single one of them has a little bit of magnetic energy. And these fields, we don't need that sign, oops. These fields organize. These groups of atoms that have similar magnetic directions organize into what are called domains. Domains are groups of atoms all spinning and sending magnetic energy in the same direction. Okay? This is what a normal object would look like, where there's different domains pointing in different directions, whatever. What's key here, though, is what happens when the domains are mostly going in the same direction. When they're mostly going in the same direction, imagine a group of people trying to get the water in a pool to splash at the same rate or move at the same rate. It requires organization to pull off, to make like a wave pool. This is a big old, well, really a microscopic wave pool, because when the domains are mostly, not all, but mostly going in the same direction, not only are they spinning their own little energies around them, those atoms, they're now pushing large amounts of energy as a whole group, okay? And so this creates a flow of energy through a magnet, creating and pushing this energy all the way out one end of the magnet, around and pulling it back in the other way. It's a giant whirlpool of energy. So magnetism comes from the magnetic fields of the atoms themselves, and these domains all flowing in the same direction, mostly flowing in the same direction. Okay? This also explains why if you cut a magnet in half, you end up with two magnets, because you still have two sets of groups of atoms with energies flowing in the same way. Two magnets. Can't separate north and south because it is set up on an atomic level. Okay? As you should already know, Earth's got a big magnetic field around it. Big magnetic field. We detect this magnetic field using a compass. You should know that a compass's purpose is not to lead you to the North Pole. It actually doesn't lead you to the North Pole. Compasses detect magnetic fields. That's their whole point. They detect magnetic fields. Okay? Now, let's think about a compass real quick. We think about a compass. A compass has a magnet in it. It's got a north, it's got a south. Okay. The north pole of the compass is attracted to which pole of the big Earth magnet? Well, the south. The magnetic south pole is actually up here near Santa Claus in the North Pole. And it's near, see that you got a red line and a blue line? This blue line is the geographic North Pole where Santa Claus allegedly lives. The red line is the magnetic South Pole. So not only are they on opposite sides of the planet, they're a little off. You need to know that. Magnetic South is near geographic North and vice versa. Now these magnetic field lines, they actually move and shift over the years. Take a look at this. These are the poles, magnetic poles of the Earth are moving. And the field lines are shifting over the years. In fact, every million years or so, the poles of the Earth flip completely. Every atom and their magnetic poles flip every so often. Some multiple times a second. The Earth every million years or so. It's been about a million years. We actually have no idea what happens to the Earth when the magnetic poles flip. No clue what happens. We do know about a million years or so ago was an ice age. Could they be connected? Who knows? Who knows? That's magnetism. That's the basics of magnetism for us. Static electricity. We're going to talk static electricity a little bit real quick. First of all, Ben Franklin. You need to know Ben Franklin was America's first famous scientist. Ben Franklin puts America on the map. United States was seen as like a lawless land of, strong country folk. Ben Franklin says we got some smart people out here like him. And he's really the father of what's called electrostatics. What I mean by that is he's one of the big original folks with electricity when it comes to electricity. The whole positive and negative that we know about with electricity is from Ben Franklin. He came up with that. You also need to know what static electricity is. It results from a tiny excess in charged particles. So you get static shock when you get a little too much charge. Okay? Now, moving on. So, like I said, I'm not going to go over everything. But just like magnets, and why we talk about this together, just like magnets, opposites attract, like poles repel. Okay? Just like magnets. But you can separate positive and negative. It is possible. I did want to mention what electrostatic induction is real quick. Okay. Electrostatic induction is a method to separate charges. Okay. It's a method to separate charges. Because opposites attract, if you bring something that is charged, like this negatively charged rod, near a neutral object, what will happen is opposites will attract and like poles will repel. The positive charges are pulled towards the negative because they like each other. And the negative charges are pushed away because they hate the negative charges. So you actually can make something charged on two different ends through electrostatic induction. It's a method to separate charges. And you do need to know that there's three methods, main methods, to separate charges. Conduction, actually pulling electricity from something, friction, and electrostatic induction. When you rub a balloon on your hair, you're actually peeling charge off your hair. The balloon peels charges off your hair. So the balloon becomes positively charged or negatively, whatever, let's say positive, and your hair becomes negatively charged. Positive and negative like each other. That's why your hair stands on end. You bring positive and negative near each other while your hair stands up and tries to go to the balloon because they like each other. With electric fields, you do need to know about electric field lines, similar to magnetic field lines, except the positive goes out, the negative comes in. Well, when you bring them near each other, well, positive and negative like each other. So, therefore, they connect. They go together. Positive and negative to create a connection. But like charges repel. Like charges repel. Okay? So, because like charges repel, let's say if something becomes positively charged, they're not going to stay bunched in the middle of an object. They don't like each other. They're actually going to coat the outside of an object. So when electricity is moving through a wire, electricity is on the outer edges of those copper wires because they don't like each other. Those charges, typically negative, don't like each other. And they will coat whatever shape it is with negative or positive charges. Famous guy named Michael Faraday that you need to know figured this out, this particular fact, using what's called the Faraday cage. Story goes, took a bird cage with a canary in it, some sort of bird, and he shocks the cage, sticks electricity on it. Bird's fine. Bird lives because charge coats the outside of the cage, not the inside. Charges don't like each other, so they didn't go inside to where the bird was. They coated outside with charge. So if you touch the outside of the cage, that's dangerous. You touch the inside, no charge, no net charge. You're safe. That's why I say if you're in a lightning storm, it's safe to be in a car. Because if lightning strikes the car, it'll coat the outside in charge, not the inside. Now, if your car blows up, that's totally different. All right. And I accidentally left these questions in there. Don't worry about that. We don't need those. We're not going to do that math. That's the basics of electricity and magnetism, or static electricity and magnetism. Hopefully that helped clarify some things. And expect to see a quiz on Thursday. And that's about it. It was nice making a video for you guys again. Hope you enjoyed it. Hope you appreciate it.